All right, guys, here we go. We're going to go ahead and finish up this review right now. So we're going to pick up where we left off, which is with question 9 on the Chapter 5 Part 2 review. We were working on talking about and going through some of the thinking process for these multiple choice questions. So for problem 9, it says the graph of f prime is shown. Which of the following statements is true? For a problem like this, it's easiest if we just go through these statements one at a time and evaluate whether they're true or false. F is decreasing on negative 1, 1. Now, just like in our free response questions, it's important to note that in this question, we've been shown the graph of f prime, which means f is going to be decreasing when this graph is below. So if I look at the section of the graph from negative 1 to 1, that section of the graph is partially above and partially below the x-axis. Therefore, it is not true that f is decreasing from negative 1 to 1. If I say, is it true that f is increasing from negative 2 to 0? The portion of the graph from negative 2 to 0 is all above the x-axis. Therefore, that is true, that is where the f is increasing. Now, although I've already identified one of the statements that's true, and although a multiple choice question is only going to have one correct answer, as a safety check for myself, I always like to go through the rest of the options just to make sure that I didn't mess something up, because if I did end up with two answers that I thought were true, then it's probably because I'm thinking about the problem wrong. So for option C, where it says f is increasing from 1 to 2, if I look at the part of the graph between 1 and 2, that part of the graph is below the x-axis, so that's false. F has a local minimum at 0. So at 0, the graph changes from positive to negative, which would actually make that a local maximum. So that's not true. And f is not differentiable at negative 1 and 1. Well, although this derivative, so in other words, the derivative of the first derivative, which is the second derivative, would not exist because those are corners, the first derivative does exist. And that means the original function is differentiable. And I can tell that because even though this is a corner, it's filled in. So the first derivative has a value, which means it must exist. So that's not true. So option B is correct. For number 10, it says the function f is given, at which the values does f have a relative maximum. When I want to find a relative maximum, I'm always going to think about looking at f prime and where it changes signs. So step 1 here is going to be to find f prime of x. Now, in order to do that in this question, I'm going to need to use product rule. So I'm going to copy the first, which is x squared, take the derivative of the second. The derivative of e to the something is just e to the something times the chain rule, which in this case would be negative 2x, plus copy the second derivative of the first, which would be 2x. If I simplify this expression, I'm going to have x squared times negative 2x makes negative 2x cubed times e to the negative x squared, plus, if I move the 2x to the beginning, 2x times e to the negative x squared, and I'm going to set this equal to 0 so that I can find the critical points. Now, in order to solve this, I'm going to start by factoring. So what these two terms have in common is the e to the negative x squared, they have a 2 in common, and they have 1x in common. So if I take out 2x and e to the negative x squared, what's left is negative x squared plus 1. Now, the thing about 2x is that that's going to equal 0 when x is 0. The thing about e to the negative x squared is that that's never going to equal 0. E to the something will never give you 0. And negative x squared plus 1 will equal 0 when negative x squared equals negative 1. So x squared equals 1, which means x equals plus or minus 1. So I'm getting two answers here. My second step is going to be to make a chart where I can look at the sign changes, just like I've done in my other problems when I need to find maximums and minimums. So I would start with negative infinity and then arrange my numbers, negative 1, 0, 1, and infinity. And again, I'm going to plug these values into my first derivative so that I can see what the the slope of the original function is doing. So if I pick a number to the left of -1, like -10, and I plug it in here, I'm going to have a negative, and then e to the something is always positive, and then -100 plus 1. So a negative times a negative makes it positive, so the original is going uphill. If I choose a number between 0 and -1, I get -1/2. So this is negative. This is always positive. And then this is going to be -1/4 plus 1, so positive. So I'm going to get a negative here. Positive 1/2 is going to be positive, positive, positive. And positive 10 is going to be positive, positive, negative, so negative. What that means is that I'm going to have a relative maximum at both -1 and +1. If the problem had asked me about a minimum, I would have said at 0. For problem number 11, it says let f be a differentiable function whose domain is 0 to 5. It is known that the first derivative is negative on the intervals from 0 to 1 and 2 to 3, and positive on the intervals from 1 to 2 and 3 to 5. Which of the following is true? And it seems from these answer choices, they're going to be asking me about maximums and minimums. So for this, I think it's easiest to organize my information into a chart. It seems that the key numbers in my chart are going to be 0, 1, 2, 3, and 5. And the domain is 0 to 5, so I don't need to go from negative infinity to positive infinity. It's going to be 0 to 5. And then I'm going to fill in the 1, the 2, and the 3. And it tells me in the problem that the first derivative, so f prime, is negative from 0 to 1 and negative from 2 to 3, and it's positive from 1 to 2 and positive from 3 to 5. Now, based on that information, I would say that I have a minimum here at 1, I have a maximum here at 2, I have a minimum here at 3, and so if I read these options, I'm looking for the one that says 2 mins and a max. This one says no mins and 3 maxes. That's wrong. 1 min and 2 maxes. That's wrong. 2 mins and 1 max. That's the winner. All right, problem number 12 is a very typical multiple choice question off of the AP test. It says the function f has the property that both f of x, f prime of x, and f double prime are all negative. Which of the following could be the graph? F of x is talking about the y values, which means if those y values are negative, I'm looking for a graph that is entirely below the x-axis. That means I can eliminate option E. F prime of x is talking about the slope. If the slope is negative, that means I'm looking for a graph that always goes downhill. So I can eliminate option C, option A. Last but not least, f double prime is talking about the concavity, which means I'm always looking for a graph that's always concave down. Since this graph is concave up sometimes, I can eliminate option D. And what that means is that B is the winner. So for problems like these, it's really just testing, do you understand what these things mean about a graph? Do you understand what f of x tells you about a graph? Do you understand what f prime tells you about a graph? And do you understand what f double prime tells you about a graph? For number 13, it says find the x values of the absolute extrema on the interval from 0 to 2. So for this problem, what I would do is take my derivative, which is 12x cubed minus 12x squared, and I would set it equal to 0 to find the critical points, which means I have 12x squared times x minus 1. And so my two values are x equals 0 and x equals 1. Then I would just make my options chart. Not my options chart, my sign chart. So from 0 is the beginning of my interval, 2 is the end, and I would put my critical points in the middle. Which means my chart's going to look like this. And I'm going to look at the sign of h prime. If I pick a number between 0 and 1, like, for example, 1/2, and I plug it into my derivative, I get a positive and a negative, which is negative. If I pick a number between 1 and 2, like 1.5, I get a positive and a positive, which makes it positive. Therefore, I would say that there is, let's see here. Absolute extrema. Therefore, I would say there's a minute 1. And that means I can eliminate A, and then what I can do to figure out absolute extrema is I need to make a chart where I include my y values so that I can see who's actually the biggest and who's actually the smallest. So I'm going to make a chart where I have x and I have h of x. I've got 0, 1, and 2. If I plug 0 into h of x, I get negative 8. If I plug 1 into h of x, I get negative 9. And if I plug 2 into h of x, I get 16 times 3 is 48, minus 2 cubed is 8, minus 4 is 32, minus 8, which makes 48 minus 8 is 40, minus 32 is 8. So it looks like my absolute maximum would be at 2, and my absolute minimum would be at 1, which means I'm going to choose option C. For problem number 14, it's kind of just an open-ended question. So just tell me everything you know about this function and how do you determine that information. So whenever I want to analyze a function for critical points, increasing, decreasing, points of inflection, concave up, concave down, anything like that, the first thing I'm going to do is take my first derivative, which is, in this case, 6x squared minus 24x, and I'm going to make it equal to 0. And the reason I would do that is that this is going to give me the critical points for this function. So I would get x equals 0, and I would get x equals 4. Next, I would take my second derivative because that's going to give me the places where I have potential points of inflection. I'm going to make that equal to 0, and if I factor, I get 12 times x minus 2, which means x equals 2. Now you'll notice I'm not just going to say that that's a point of inflection. These are critical points automatically because critical points are just places where the derivative is equal to 0. Points of inflection, the concavity has to actually change. So I'm not going to make that my final answer until I make a chart where I can see if the concavity actually changes. So the beginning of my chart is going to be negative infinity and the end will be infinity. In my chart, I'm going to put in the 0 and the 4, which were my critical points, and I'm going to put in the 2, which is my potential point of inflection. I'm going to make 2 rows in my chart. The first row is going to be all of the information that I know about the first derivative. So if I pick a number to the left of 0, like negative 1, for example, I would get negative times a negative makes it positive. Now I'm going to pick a number between 0 and 4. I'm not going to worry about 0 to 2 and 2 to 4 separately because the 2 was only an important value when I'm talking about the second derivative. So the first section here would be negative infinity to 0, and then I'm going to do 0 to 2. For 0 to 4, which means I'm actually going to use the number 2 and plug that into my first derivative. Positive times negative makes it negative, negative for both. And then a number that's bigger than 4, like 10, for example, positive, positive means positive. Now for my second derivative, my sections are really just 0 to 2 and 2 to infinity. So for the second derivative, I would have from 0 to 2, I'm going to use 0, which means it's negative, so it's concave down this whole time. And then from 2 to infinity, I'm going to use 10. I'm going to have positive, which means it's concave up this whole time. Because the concavity actually does change here, it turns out x equals 2 really is a point of inflection. But if the concavity had not actually changed signs, it would not be a point of inflection. So it's really important whenever you're asked about points of inflection to verify that the concavity actually changes signs there. So don't just assume that because the second derivative is 0, that that's enough. It actually has to change there. Once I have this chart made, filling in the rest of this information is pretty straightforward. So increasing would be negative infinity to 0 and 4 to infinity. Decreasing would be 0 to 4. And you'll notice I'm using closed brackets because that's how it's defined, is that the first derivative is greater than or equal to 0, or conversely, less than or equal to 0. For concave up, I would say from 2 to infinity. And for concave down, I would say negative infinity to 2. And again, that has to do with how it's defined. It's greater than or less than. There's no equal to. For a maxima, I'm going to envision connecting these arrows, which means I have a max at 0. And for a minimum, I'm going to imagine connecting these arrows, which means I have a min at 4. So x equals 0 and x equals 4. My last step here would be to sketch my graph. Now, in order to do that, I need to have one more piece of information, which are the specific y values that go with these x's. So if I take the 0 and I substitute it into my original function, I get 0, 0. If I take the 2 and I substitute, I get 16 minus 48, which is negative 32. And if I take the 4 and I substitute it into my original function, I get, 64 times 2 is 128, minus 4 squared is 16, and 16 times 12, I don't know what that is. 16 times 12. So that would be 2, and 2 times 3, and then 16, so 192. So 128 minus 192 means I get 4, negative 64, I believe. Okay, so my values then on my graph, 0 is an important x, 2 is an important x, and so is 4. Negative 32 is an important y value, and negative 64 is an important y value. I'm going to graph 0, 0. I'm going to graph 2, negative 32, and 4, negative 64. Now, everything to the left of 0 is uphill but concave down. In between 0 and 2, it's downhill but concave down. Then downhill and concave up, and then uphill and concave up. All right, last but not least, the last topic in this chapter was the idea of optimization, which is taking this idea of a max or a min and just putting it in a real world problem. Now, this is definitely something I would suggest that you go back and you review a lot and that you do a lot more practice problems with, but here are just 2 problems that we can use to help us review this idea. So problem number 15 says, find the maximum volume of an open box that can be made by cutting out congruent squares from the corners of an 8 by 15 regular sheet of cardboard and folding the sides. So what it's telling me is that I'm starting with a piece of cardboard that is 8 by 15. Now, a good strategy here is always going to be to start by drawing a picture. I'm going to cut out the corners, and by folding up those corners, it's going to make an open top box, which means a box with the sides and the bottom, but no top. Now, because I'm cutting out squares, I'm going to make all of these x by x. Now, I want to find the maximum volume. So if I picture this imaginary box that I'm building in 3 dimensions, the new width of the box is going to be 15 minus 2x, because you're taking off a size x square from the right and a size x square from the left. The new depth of the box is going to be 8 minus 2x, and the height of the box is going to be x. which means the volume, which is what I'm trying to maximize or minimize, in this case maximize, is going to be 15 minus 2x times 8 minus 2x times x, or in other words, length times width times height. Now, if I multiply all of this out, my life's going to be a lot easier when it comes to taking the derivative, because anytime you want a maximum or a minimum, you need to take the derivative. So if I multiply this out, 15 times 8 is 90. I'm sorry. Is 15 times 8 90? No, it's 120. What am I doing? And 15 times negative 2x is negative 30x. Negative 2x times 8 is negative 16x. Negative 2x times negative 2x is 4x squared. And we still have this x over here. I can combine like terms, and I get 120 minus 46x plus 4x squared times x. If I distribute that x, I get 120x minus 46x squared plus 4x cubed. Now that's kind of step one, is to get a formula for the thing that you're trying to either maximize or minimize. Step two now is take the derivative and set it equal to 0. So the derivative of this formula would be 120 minus 92x plus 12x squared equals 0. Now we could go through the process to solve this by factoring or whatever. I'm going to tell you for the sake of time that I'm going to give you a problem on the assessment that's a lot easier to actually work through if you have to do all the algebra. In this case, I'm going to solve it using a calculator by just finding the zeros. And so when I do that, the value that I get is 1.667 inches. Now that means that the size of the corner that I should cut out is 1.667. The problem is it doesn't ask me what is the size of x. It says what is the maximum volume. So what I'm going to do now is take this x and resubstitute it, and my volume would be 90.741 inches cubed. In the next problem, we'll actually go through a process where we solve it without a calculator. It's just for the sake of time, I'm not going to go through that process for this one. For problem number 16, it says a rectangular page is to contain 24 inches squared of print. The margins at the top and the bottom are 1.5 inches, and the sides are each 1. So we have to imagine we have some sort of print in the middle of our page, and there's a border around it, because usually when you print something, it doesn't go all the way to the edges of the paper. It tells me that the interior size is 24 inches squared. And it tells me the margins at the top and the bottom are 1.5 inches. And the left and the right are each 1. Now it says, what should the dimensions of the entire page be so that the least amount of paper is used? Now the idea here is I want the dimensions of the entire page, but I want to use the least amount of paper possible. So we're going to take two things into account. We're going to take into account that we know the interior size, and we're going to take into account that we have this bigger paper that includes the margins around it. Since we know the interior size, I always label that interior dimensions as X and Y. We don't know if it's 2 by 12 or 3 by 8 or 4 by 6, but we know the interior dimensions total have an area of 24. So I can say for sure that X times Y is 24. Now, the overall area for the whole paper would be x plus 1 plus another 1, which makes x plus 2 for the total width. And then y plus 1.5 on the top and 1.5 on the bottom. So y plus 3 for the total height. It's important to notice that for this problem, we actually have two formulas. And the reason we need two formulas is that when you have two variables, you need two formulas. We're going to take this first formula and we're going to rearrange it so that we have x equals 24 divided by y. You could also, if you wanted to, rearrange it so that you have y equals 24 divided by x. This step right here is really step one. Get two formulas if you have two variables. The second step is to substitute so that your formula that you're trying to maximize or minimize only has one variable. So my overall area would be equal to 24 over y plus 2 times y plus 3. Now, eventually I know, because I'm trying to find a max or a min, I need to take the derivative and set it equal to 0. So this is going to be a lot easier if I distribute, which means I'm going to have 24 plus 72 over y plus 2y plus 6, which simplifies to 30 plus 72 over y plus 2y. That right there is what I kind of consider step 2. Get your formula to only have one variable. Step 3 is now to take the derivative. So the overall area derivative would be, the derivative of 30 is 0. This is really 72 y to the negative 1. So your derivative would be negative 72 over y squared plus 2 equals 0, which means we would get 2 equals 72 over y squared. If we multiply by y squared, we get 2y squared equals 72. So y squared equals 36, which means y would have to be 6. Although negative 6 squared is also 36, since y represents the dimensions of a piece of paper, it can't be negative 6. So y would be 6, which means if I take my number and I substitute it back into this formula, I would get that x is 4. But that right there is not my final answer. It asked me in the problem for the dimensions of the entire page. X and Y were just the dimensions of the interior area. So for the overall dimensions, I would take Y and plug it in here, which means I would have 9 inches tall by, if I take 4 and I plug it in, I would have 6 inches wide. And that would be my final answer. All right, I hope that this has been helpful to go through the review together, and I hope everyone is more successful on the retake.